Today everyone, today we will tackle the proof using Venn diagrams, especially our main focus is verifying De Morgan's law and absorption law visually. So again, good morning everyone. So in this presentation, we will explore how Venn diagrams can be used as a powerful visual tools to prove important set identities in mathematics, specifically De Morgan's law and the absorption laws. Instead of using only a symbolic manipulation, we will rely on shading and interpretation of Venn diagrams to clearly understand how and why this law works. By the end of the lesson, you should be able to first understand the basic set operations such as union, intersection, and complement using Venn diagram. Second, visually verifying De Morgan's law by comparing shaded regions. Third, illustrate and prove the absorption laws using Venn diagrams. And finally, interpret shaded regions accurately to match algebraic set expressions. These skills will help you approach set theory proofs with confidence and clarity. Let us begin with De Morgan laws, which are two fundamental identities in set theory. This law describe how complements interact with union and intersection. The first law states that the complement of A union B is equal to the intersection of A complement and B complement. That is this one. So the second law states the complement of A intersect B is equal to the union of A complement and B complement. So this one, the second one. These laws reveal an important duality in set theory. In set theory, union and intersection switch rules when taking complements. We will now use Venn diagram to prove the first law visually. So let us start the expression, the A union B complement. So the first step is to find A union B. A union B include all elements in A and B or in both. So, if we imagine our Venn diagram, this is the entire region covered by both circles. Now, we take the complement of the region. The complement includes everything outside the union. So, in our shaded, this one. So, in our shaded, diagram, all areas inside circles A and B remain unshaded, while everything outside the circle is shaded. The shaded region represents the set of elements that do not belong to A nor to B. So now let us look at the expression A complement intersect B complement. First, shade A complement. This is everything outside circle A. Then, shade B complement. This is everything outside the circle B. To find A complement intersect B complement, we focus only on the area where both shading overlap. And what do we notice? So, the overlapping shaded region is exactly the area outside both circles A and B, identical to the shading in the previous diagram for A union B complement. This shows something important. So, both expressions produce exactly the same region. So, by comparing the two Venn diagrams side by side, we can clearly verify De Morgan first law. So, the diagram for A union B complement shades everything outside the both set A and B. The diagram for A complement intersect B complement also shades exactly that same region because the resulting shaded areas are identical. We can confidently conclude that A union B complement equal to A complement intersect B complement. So this visual method removes the needs for symbolic manipulation and instead give us a clear and intuitive confirmation. So now let us proceed to the absorption laws, which help simplify expressions involving sets. So these are two absorption identities. The first one is A union set of A intersect B equal A, and A intersect set of A union B equals to A. So these laws tell us that when a set is already included in a larger expression, that larger expression simplifies back to the original set, the larger operations gets absorbed by A because adding something that is already inside A does not change the result. To better understand this so let us now illustrate one of the laws using a Venn diagram. So this one, so we have here A intersect set of A union B. So first identify the A intersect B. So this is simplify the overlapping area between A and B. We shade that intersection. Next, take the union of A with that shaded part. Since A intersect B is already inside A, adding it does not change the boundary of A. So the final shading becomes the entire circle A. So this shows that A union set of A intersect B simplifies to A. The A absorbs the intersection because it's already part of A. So this visual proofs clearly confirms the absorption law. To summarize, Venn diagrams offer a powerful and intuitive ways to understand and prove set identities. Through visuals comparison, we verified De Morgan's law by showing that the shaded region of A union B complement and A complement intersect B complement are identical. We also demonstrated the absorption law by showing how the union of A with its intersection with B still result in A. Visual proofs like this help transform abstract algebraic expression into concrete. So, for understandable ideas. Thank you for listening, and I hope this presentation strengthens your understanding of set theory and visual reasoning.